let me start with another example. Let's say you have f of x equal to following. It's 1 for x between 1 to 2. And then it's x squared for x between -1 to 1. And then it's again 1 for x between -2 to -1. Now, if you calculate the Fourier series of this, it's rather very complicated. So actually, instead of asking you to find the Fourier series of the entire thing, I'll just ask, find the first 5 non-zero terms of the Fourier series. And then if you can write down the first 5, then trying to find the generic formula will be just one step harder. If you really need it, you'll be able to do it. For this problem, we'll be just content with just having this much, okay? All right, so let's try to solve this question. First, let me draw the graph to convince you of the symmetry it has. So from 1 to 2, -1 and then -2. From 1 to 2, it's 1. Also from -2 to -1, it's like that. But between -1 and 1, you have this parabola. Because y equals x squared is a parabola, right? And they actually meet, because if you plug in 1 and -1 here, you get value of 1 in both cases. So you actually have a graph that's like this, which you can think of it as a closed circle here and an open circle here, because at -2 it's not defined. However, if you take the Fourier series of this, then it means that you're trying to make a periodic function out of it. So you're going to get this, 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 then this, and it's going to repeat. Okay, so that's the function that you're thinking of. Okay? And by the way, the resulting periodic function is continuous everywhere. Therefore, the Fourier series will be exactly matching this function. Okay. All right. Looking at this, is this an even function or odd function? It's an even function, because if you fold it along the y-axis, it's going to match. Okay. You might complain about this being an open circle, whereas that's closed, but it doesn't matter, because when we say we're doing the Fourier series, we're actually thinking about the periodic extension of this function. So it's, that's what we get. Okay. All right. Since it's even, the function will be a0 over 2 plus sigma, and from 1 through infinity, an cosine. What's the value of L for this case? 2. Right? Yeah. So the formula is n pi over Lx, but because the L is negative L to L, with L equal to 2 is our case, L should be taken to be 2, and that's why we write. Now, do we need Bn?
No.
No, because Bn are odd functions, and since fx is an even function, you're only going to see even functions appearing. There won't be any odd functions. Okay. All right. Then, what's the formula for an? An is 1 over L from -L to L, f of x cosine n pi over Lx dx. In our context, since L is 2, it's like integrating from -2 to 2 of 1/2 f of x cosine n pi over 2 x dx. What should we do after this?
Times by 2.
Times by 2, and cut the integral in half, right? Why is that possible?
Because it's going from -2 to 2.
No, because this function is even, that's even, even times even is even, and if you're integrating an even function, you can take a symmetric domain, cut it in half, and times it by 2. We're using the property that the integrand, the thing that we're integrating, is an even function. That's important. If it's not an even function, this cannot be done at all, okay? It's only because it's an even function. All right, now, so since 2 over 2 is just 1, we can just ignore that. However, even though we have the function values only for 0 to 1, still we have 2 different functions from 0 to 1. Do you see that? Right. And therefore, unfortunately, to calculate this, we have no choice but to actually split the interval in 2. What interval should we split into? 0 to 2 should be split into 1 and what?
0 to 1.
0 to 1 and 1 and 2. Okay? It has to be done in 2 intervals. Okay, so this is 1, so we don't care. We just drop, get rid of this. And then instead of from 0 to 2, we write it as 0 to 1 cosine n pi over 2 x dx plus 1 to 2 cosine n pi over 2 x dx. And I put blanks here because now I can actually use this to fill this in. What should I fill this one in?
X squared.
X squared, because from 0 to 1, it's in, for this case, right? From 0 to 1, it's this case, and x squared is what f of x is in that interval, okay? Now from 1 to 2, what should I do? Use 1, because the value of the function is 1. And therefore, we have to calculate that. Now the first integral requires integration by parts or tabular, but since I like tabular so much, I'll try to use tabular to calculate. So let's see. I do g an integral plus minus x squared, 2x, 2, and 0. And cosine n pi over 2x, if you integrate that sine n pi over 2x and put the reciprocal in front, is 2 over n pi. Remember, anything that you have, the reciprocal should be put in the front whenever you do the integrals. Integrating sine gives you negative cosine, and because another one of these reciprocal appear, you'll get 2 over n pi squared cosine n pi over 2x. And the third one, it's another integral pops up, another coefficient pops up, and therefore you need the third power with the sine n pi over 2, and that's all I need because it hits 0 here, okay? And then it's plus, minus, plus, minus. Now you multiply it out to calculate the integral this way, like that. Okay. So let's write down the result over here. It's rather long. What is it? It's 2 over n pi, that's the coefficient, and x squared sine, that's what you get. X squared sine n pi over 2x. And then negative times negative is positive, right? And 2, this is 4 over n squared pi squared, but 4 times 2 is 8, so you end up with positive 8 over n squared pi squared x times cosine n pi over 2x. The third one, 2 cubed is 8. 8 over n cubed pi cubed. And there's a 2 there. 8 times 2 is 16. And it's a minus because there's a minus here. So that's a minus of 16 over n cubed pi cubed sine n pi over 2x. And then that has to be evaluated at 0 and 1. That's the first integral. Now for the second integral, cosine integrates to sine, and the coefficient of x should be flipped, and you put it in front, so it's 2 over n pi sine n pi over 2x. And this one you evaluate from 1 to 2. And these two should be added up. All right. Then you plug in 1. Let's see what you get if you plug in 1. If I plug in 1, it's 2 over n pi. 1 squared is 1. And you get sine of n pi over 2. Plus, when you plug in 1, that's 8 over n squared pi squared. And cosine of n pi over 2. And then when you plug in 1 here, that's minus 16 over n cubed pi cubed sine n pi over 2. And then plus, what's this? This is when you, oh, no. I forgot to plug in 0, right? If I plug in 0, anything that has x in there will be 0. And sine of 0 is? 0. Oh, so when you plug in 0, nothing happens. So this is minus 0. For this one, when I plug in 2, what do I get? Sine n pi. What's sine? Yeah.
With the other right.
Yeah. Yeah, when you plug in 2, 2 and 2 cancels, and you get sine n pi. What's sine n pi? What's sine n pi? 0. Sine gives you 0 at n pi. Okay. So it's 0. And when you plug in 1, you get plus 2 over n pi. No. Yeah, 2 over n pi sine of n pi over 2. And then if you look at this result closely, I see that this is same as that, isn't it? Right? So we have this, we can put them together, and we have a nice result. Let's see, let's delete it. We have a nice result which says that an must equal to this plus that doubles, so it's 4 over n pi sine n pi over 2 plus, oh, what's cosine n pi over 2? Well, it's, if n is odd, it's 0, right? If n is even, it's not 0. Okay, so I thought this could be just gone, but it's not. It's still need to write it, unfortunately. Okay, and then this one, minus 16 n cubed pi cubed sine of n pi over 2. So that's your an, and as I said, that's why I was asking for the first 5, because some of these become 0 for n being even or odd, so it's rather complicated. I mean, you could rewrite this as n equals to 2m and 2m minus 1, separate the case when it's even or odd, and come up with some formula there, but it's just too much, so that's why I'm asking you that. Now, important. We forgot a very important step when you try to calculate the ANs. There's a very important step. I don't think anybody will remember. It was in the presentation, but I don't think it remembers. So it happens that this is not always valid. Why? I thought it was. This is only for what? N greater or equal to 1. Okay? What happens if n is 0? You get cosine 0 is? What's cosine 0? 1. Cosine 0 is 1. So A0 has to be calculated separately. A0 is 1 over 2, negative 2 to 2 of f of x times 1 dx. And the integration of this is completely different from the other case because this function, this is not a cosine function, so there's no need for tabular integration and all that. Yes?
Shouldn't it only be for -1 and 1? Like the interval? Because like up for where you have f of x, you have x squared only for -1 and +1.
No, it's
No.
from the negative
Okay.
L to L. Our L value is 2.
Oh, so I'll never
it's
change
from negative 2
regardless
to
of
2.
what the function is for, like what interval that function's for?
Yeah, it's from negative 2 to 2, so it's from negative 2 to 2.
Okay.
All right. Again, you can use the fact that it's an even function. And then integral from 0 to 2 now has to be split into the integral from 0 to 1 and integral from 1 to 2. Where this one is the integral of 0 to 1 of x squared dx. And this one is the integral of 1 dx. Right? From 0 to 1 it's x squared. From 1 to 2 it's 1. Integral of this is 1/3 x cubed. You have to evaluate 0, 1 and 0. Plus, integral of 1 is just x, and you have to evaluate 2 and 1. Plugging in 1 gives you 1/3. Plugging in 0 gives you 0, it's minus 0. Plus, plugging in 2 gives you 2. Minus plugging in 1 gives you 1. So you get 1 plus 1/3, which is 4/3. I did that part rather quickly because it's kind of trivial. All right. So that's what we have so far. And now let's actually write down the function. Before that, what's A1? Sine of pi over 2 is 1. Cosine pi over 2 is 0. This is 1. So A of 1 has 4 over 1 pi minus 16 over 1 pi cubed. That's it. 4 over pi minus 16 over pi cubed. Now A of 2. In that case, if I plug in 2, it's sine of pi. What's sine pi? 0. What's sine of cosine of pi? -1. So A2 will have these two become 0, and this one will be -1. So it's negative pi 8 over n squared pi squared. I said first 5 non-zero terms, so A0, A1, A2, A3, A4. Those are the ones that we need. Okay, A3, A4. Again, for A3, this one will be 0 and these will be non-zero. And sine 3 pi over 2 is -1, so it will be -4 over 3 pi plus 16 over 9 cubed pi cubed. Okay, don't bother, sorry, not 9 cubed, 3 cubed.
Would this be for A?
Oh, that's A3, sorry. This is A3.
For A2,
Yes.
see 4 on the bottom.
Oh, thank you. This should be 2 squared, which is 4. Okay. Yeah, this should be 27. And then A4, what would that be? A4, cosine 2 pi is 1. Therefore, you get 8 over 16, which is 1 over 2 pi squared. So it's 1 over 2 pi squared. That's your A4. Okay. Again, when you plug in 4 here, and you get sine 2 pi and sine 2 pi there, those are 0. Okay. So those are the values. And now we can actually write down our function. Okay. Remember, there's an over 2 there. So if I write it down, what's the answer? So the final answer is f of x equal to A0 over 2, that's 4/3 divided by 2, which is 2/3, plus 4 over pi minus 16 over pi cubed times cosine pi over 2x